nested subqueries and replacing joins with subqueries. We can sometimes replace a join with a subquery, and it can make the query faster. Let's take a quick look at this query. In this query, we're selecting from ticket, show, and category. The columns we're selecting come from the category table, the show table, and the ticket table. Here's the join for the three tables, and here are the join statements. There's one thing that we can actually do to speed this query up. First of all, the filtering should be applied first on the first line of the where clause. What we would need to do is to filter out the shows we don't want. So we find all the shows that are on this date and we apply that first. After that, we would actually apply the join between the ticket and the show table. So these two lines would be the other way around, as shown here. Now what I've done is I've actually taken out the access of the column or the count function from the ticket table. We'll see why in a minute. Back to the filtering. The filtering is now on the first line, so it means that when we effectively, if this filter was up here on the first line, when we joined between the show and the ticket table, we'd actually be joining fewer rows because we'd have fewer show records. Aside from filtering, look at the difference between the joining in this query, 3 tables, and the joining in this query, 2 tables, and they're very small. The show and category tables are around about 1 to 200 rows, and the ticket table is over 200,000. That's a vast difference. Now let's say in this query I didn't need this count from the tickets table, so I simply join these 2 tables, but I want to know that what I'm joining from show and category actually exists in the ticket table. So what I can do is I can pass the ticket join, because nothing is being selected from it, down into a subquery, and here we have it. We say and exists, select show ID from ticket where the show ID is equal to the correlation of the show alias from the calling query. Now let's show you another example. Here we're selecting the venue and the seat from the ticket and venue tables and joining them. Here's the join down here. What the exist clause is going to do here is going to attempt to filter some data out so that we join between fewer rows. In other words, we're going to try and filter out some venues or some tickets. What this SQL statement is doing is selecting particular shows based on a show date, and it's also selecting particular shows based on a category. So what we've actually done is we've taken the join from ticket, venue, show, and category and changed it into a join between just the ticket and venue tables. Here's an expanded version of that query where we join between all the tables at once. The filtering is once again up the top, but look at the size of the join. We are doing filtering at the top, and we're doing the smaller tables at the top. It is quite possible that this version would be faster than this version. The performance difference would largely depend on the number of rows in the different tables and the relative numbers of rows between the different tables. Here's another variation on the same thing. Since we're not selecting from the category table in this query, we can put the category table into a subquery. This should really be the fastest version of this category subquery because it's using an equijoin. If we were to use exists, this exist version would probably be faster than in if the category table was large, which it is not, so the chances are in and exist would probably be the same speed. Let's go through a few examples showing what we can do with subqueries. First of all, I'm going to set my columns so I can see what's going on. This is a count of a very large join between 5 tables. This would retrieve a large number of records. Now the idea when writing good performing SQL code is to reduce the number of records that we join. In other words, we don't want to join a large number of tables, get a huge join, and then filter out a lot of those records. So for instance, this query would probably give us a huge result, although we have filtered it by theater. And there we have it, 17,000 rows. Not really the kind of number of rows we want popping up on the screen and scrolling past us. A little bit meaningless. Let's first of all go and find the smallest number of rows in the ticket table based on the show ID. Down the bottom we can see we have 800 rows on the 28th of May. So we know we've got at least 800 rows. Now let's go and find a specific set of tickets. Ice shows, 23rd of October 2002. Now let's do a very complex, well, what looks like a very complex SQL statement, but it's actually a multi-layered nested subquery. Here we've actually selected the category for ice shows. Based on that, we've selected the shows on a particular date for that particular category. Pass that result up to this query, which selects everything from that query and applies the ticket and show join. The result from this query are the ticket records we need. In the main calling query, we join the venue and the ticket tables based on this join. So let's run this query and see what it looks like. We get 800 rows coming out of there. All I'm trying to do is show you working queries with lots of nested subqueries.